What if one morning you looked up and there were two suns in the sky? Jupiter, the largest planet in our solar system, suddenly begins to glow. Its clouds ignite, its gravity shifts, and the entire solar system starts to unravel. Could Earth survive if Jupiter became a star? The spark of a new sun, Jupiter, is already massive, more than 300 times the mass of Earth. But here's the thing, it's almost a star already. Just like the sun, Jupiter is made mostly of hydrogen and helium. The only reason it is not shining right now is that it's too small to trigger nuclear fusion, the process that powers real stars. If it were about 80 times more massive, Jupiter would ignite and become a small star called a red dwarf. But if that ever happened, it would be the end of the solar system as we know it. The moment it ignites. Let's imagine it happens suddenly. No warning, no buildup. Deep within Jupiter's core, gravity compresses the gas so tightly that hydrogen atoms begin to fuse into helium. The planet bursts into light. The faint glow we see from reflected sunlight becomes a fierce radiance of its own. Temperatures rise to thousands of degrees. Radiation floods space. And now, the solar system has two stars. Earth's double sunrise. From Earth, it would be breathtaking and terrifying. Each morning you would see two suns rise. The first, our familiar sun. The second, a smaller reddish light glowing beside it in the sky. At first, it might seem beautiful, but that beauty would not last long. Because two suns mean double the gravitational pull, and the delicate balance that keeps our planets in line would begin to break apart. The gravitational war. Our solar system works like clockwork because every planet moves in harmony around one sun. Adding a second star would throw that harmony into chaos. If Jupiter became a red dwarf, its increased mass and radiation would alter the orbits of nearby worlds, especially Saturn and the asteroid belt. Their new paths would push debris toward the inner solar system, bombarding Earth with asteroids. Even slight shifts in gravity could send our planet drifting closer to the sun, or fling it into deep space. In short, two stars mean one unstable solar system. The sky catches fire. If Jupiter suddenly started shining, the outer solar system would light up like never before. Its moons, Europa, Ganymede, Callisto, and Io, would bask in the new heat. Frozen surfaces would melt. Subsurface oceans could boil. Volcanoes on Io might erupt non-stop, turning the moon into a glowing ember. But the inner planets would suffer too. The combined radiation from two suns could heat Earth's atmosphere beyond survival. Oceans would evaporate, ice caps would vanish, and global temperatures could rise by tens of degrees. The blue planet would start to look more like Venus, dry, clouded, and deadly. Could life survive? At first, life might try to adapt. In the oceans, some deep-sea organisms could survive longer, protected by water. But on the surface, plants would wither. Photosynthesis depends on precise light levels, and two suns would overwhelm that balance. Animals would struggle to find shade or water. Within a few centuries, or even decades, Earth's biosphere could collapse entirely, unless we found a way to leave. Humanity's dilemma. For humans, this event would be the ultimate test of survival. We could attempt to build shelters underground or beneath the sea, using technology to filter radiation and cool the air. But the challenge would grow each year as temperatures continued to climb. The only real solution might be escape, leaving Earth and finding a new home elsewhere in the solar system. Ironically, the moons of Jupiter might now be warm enough to support life. Europa, once a frozen ocean world, could become a tropical water planet under its parent star's heat. If humanity could reach it in time, we might find our second chance there. The moons of the new sun, Jupiter's moons, would undergo the most dramatic transformation of all. Before ignition, they were icy, cold, and silent. After ignition, they would awaken. Europa's ice crust would melt, revealing a global ocean beneath. Ganymede's thin atmosphere would thicken. Callisto could develop clouds and rain. Io, already volcanic, would erupt endlessly, glowing like lava under the new light. These moons could become miniature worlds, orbiting a newborn star, each one a candidate for colonization. But they would also be dangerous. The radiation from a newborn red dwarf would be intense, and without magnetic protection, any life there would need shelter underground. Even paradise would come at a cost. How Jupiter would look. A red dwarf star is smaller and dimmer than the sun, glowing orange-red instead of white. From Earth it would appear about 1/10 the brightness of the sun, still enough to cast light and warmth, but eerie and unfamiliar. The night sky would never be dark again. Depending on its position, Jupiter's glow could dominate the evening sky, turning the darkness into a copper-red twilight. It would feel like an endless sunset, haunting, beautiful, and slightly wrong. The changing orbits with Jupiter's new gravity, every planet's orbit would begin to shift. Mars might drift closer to the sun, while Earth's path could slowly warp. Over time, the two stars would begin orbiting each other as a binary pair, with the planets caught in their gravitational dance. That dance could last millions of years, or it could spiral into disaster. If their orbits crossed too closely, the two stars could eventually collide. And when two stars collide, the explosion can be brighter than an entire galaxy. A system reborn. Let's say the solar system stabilizes instead of collapsing. Over time, the twin stars would settle into balance, orbiting a shared center of gravity. Earth might move farther away, finding a new, cooler orbit. The night would glow faintly even without the sun's direct light. Temperatures might rise, but the system could survive. It would be a new kind of solar system, one filled with endless light and shifting beauty. But even in this best-case scenario, humanity's home would never be the same again. Why Jupiter can't become a star? Naturally. Here's the truth. Jupiter can never ignite on its own. It simply doesn't have enough mass. To start nuclear fusion, it would need to be at least 80 times larger than it is now. Even if we added every planet in the solar system to Jupiter, it still wouldn't be enough. That's why astronomers call it a failed star, big enough to resemble one, but too small to burn. Instead, Jupiter shines faintly from the heat it produces as it slowly contracts. It's a gas giant, not a fireball. So, while it looks like a miniature sun in infrared light, it will always remain a planet. What if we forced it? What if humanity tried to make Jupiter a star? If advanced civilizations ever existed in our galaxy, some might have experimented with stellar engineering, using technology to ignite planets. We could, in theory, dump massive amounts of matter into Jupiter to increase its mass until fusion begins. But the energy needed would be unimaginable. We'd have to move dozens of gas giants or steal material from entire stars. Even then, the explosion of ignition could vaporize everything nearby, including Earth. So, while the idea is fascinating, it's one we could never safely attempt. What the solar system would look like. From far away, a double-star solar system would shine beautifully. Two stars orbiting in harmony, each illuminating the other's planets. Jupiter's red glow reflecting off Saturn's rings. Europa sparkling with melted oceans. The asteroid belt gleaming under twin light. It would be the kind of beauty you could only see from the distance of space. Breathtaking, but deadly up close. The long-term fate. Red dwarfs burn much longer than stars like the sun. While our sun will die in about 5 billion years, a red dwarf could burn for trillions. If Jupiter became a red dwarf, it would outlive the sun by 1,000-fold. When the sun finally dies, Jupiter would remain, a small, fading ember in the dark. Its moons might freeze again. The heat would fade, the glow would dim, and the system would fall silent once more. The brief age of two suns would end in darkness. The human view. For humans looking up at the sky, it would be the most awe-inspiring event in history. To see another sun born in your lifetime, to watch Jupiter ignite and reshape the heavens, would change how we see the universe forever. Poets, scientists, and dreamers would call it a second creation. But for those living on Earth, it would also be a warning. Even beauty can destroy. Why this matters. The thought of Jupiter becoming a star helps scientists understand what makes our solar system stable and why life exists here at all. Too much gravity, too much light, or too much heat, and balance is lost. We live in a perfect equilibrium that allows water, air, and life to coexist. A second sun would break that equilibrium instantly. It reminds us that existence is fragile, not guaranteed, but precious. If Jupiter became a star, it would light up the sky and tear the solar system apart. Planets would shift, moons would melt, and Earth would burn. It would be both the most beautiful and the most catastrophic event in human history. And yet, as we watched from the last safe corner of our world, we would understand something deeper. The same universe that can destroy also creates. The same laws that give birth to stars also shape the fragile balance that allows us to exist. And maybe that's the real miracle. Not that Jupiter could become a star, but that it hasn't.